So the title is the effects of lysine and energy intake during that late gestation on specifically the birth weight of the pig, also how those animals, those sows and gilts gain weight during that late gestation, as well as the reproductive performance. Okay, so bump feeding, as we all know, is generally defined as increasing the amount of feed during late gestation. Cromwell and others, in 1989, they conducted a study around 8 universities with 1,080 animals, so a very large scale study, and they observed a 40 grams increase in the birth weight of those pigs, and that was when they bump fed gilts and sows. 2009, Nick Sheldon and others at Kansas State University, as well as in 2011, Jose Soler and others at Carthage, they observed an increase in piglet birth weight only when they bump fed gilts, but they didn't observe that when they bump fed sows. Based on that literature, we had a couple questions. First, is that improve coming from amino acid, or is coming from energy, or maybe an interaction of both? Also, how would that happen in a commercial herd with, say, 14.5 total born? So to answer some of these questions, the objective of our study was to determine the effects of lysine and energy, again, during late gestation on that reproductive performance of gilts and sows. The animals were individually housed from day 0 to day 40, and I should mention that we used 1,102 females, which generate more than 15,000 baby pigs at birth that we weighed individually, and so most of them were gilts, and 361 of them were sows, PIC 1050s. So again, they were individually housed from day 0 to day 40 when they were moved to a pen where they were group housed with a ESF. At day 90 of gestation, we started our study that went all the way to day 111. During lactation, they received a common diet. So our treatment structure on that late gestation was a 2 by 2 by 2 factorial, having 2 levels of parity, either gilts or sows, and 2 levels of lysine, 10.7 or 20 grams of SID lysine intake per day, and also 2 levels of energy, 4.5 or 6.75 megacal of net energy intake per day. As far as the design structure, the females were housed in pens by parity level, so either gilts in pens or sows. They were blocked within pen by body weight, and they were individually and randomly assigned to each of the dietary treatments. As far as the statistical analysis, we conducted a generalized linear mix model, where pen was the experimental unit for parity, and the female was the experimental unit for the dietary treatments. We used also a bump-for-run adjustment to adjust for the multiple comparisons, and the feeding stations were calibrated twice a week. So it shows our diets here. You can see in the picture we had 2 feed lines in the farm, so that posed us with a challenge. So okay, we have these 2 feed lines, and so how are we going to get to the treatments that we want? So after some calculations, we end up deciding formulating 2 diets, one at 0.4% SID lysine, and the other one at 1.06% SID lysine. You can see the diets were mainly corn and soybean meal based, and we kept the synthetic lysine fixed between the diets. All the other nutrients and amino acids met or exceeded the NRC 2012 recommendations. So to show you how we got to our dietary treatments, with those 2 feed lines, we blended different levels of them through the ESL system, and you can see as the SID lysine in the diet increased, the net energy per kilogram decreased, and that is because we have more soybean meal in that high lysine diet, and soybean meal has less net energy than corn, so net energy went down. So basically, we provided different levels of these diets to reach our main goal, which is at the 2 by 2 factorial here for the dietary treatments. Again, 10.7 grams versus 20 grams of SID lysine, and 4.5 versus 6.75 megacal of net energy intake per day. The chemical analysis, as you can see, crude protein, total lysine were well within the values we were expecting. That was Very, very good information. And now moving to the results here, I just like to take the time to explain these slides for you. On the horizontal axis here, we're going to have the 2 levels of SID lysine and the 2 levels of net energy. Okay? And on the vertical axis, we are going to have the response variable, which in this case, the body weight gain from day 90 to day 111 of gestation. As you can see, there is a lysine by energy interaction. There is also a parity by energy interaction. First, let's take a look at the lysine by energy interaction. Basically, in the high energy intake, the body weight gain increased 5.3 kilograms with increasing lysine, but in the low energy, when we increase lysine, it increased 3 kilograms. So basically, when we increase lysine and energy simultaneously, the animals gained more weight, which is very interesting. We know that there's a lysine to calorie ratio in growing pigs, and that's, to my knowledge, the first report of that nature in gestating sows. Now let's take a look at the parity by energy interaction. Basically, compared to the high energy, the low energy decreased the body weight gain by 6.5 kilograms in Gilts, which here is in purple, and 8.8 kilograms in sows, here in red. As we move to the total piglets born, our treatments were applied late gestation, so definitely we didn't expect any response there. However, you can see that sows had more piglets than Gilts. Looking to piglets born alive, here we find an interesting finding where there's a parity by energy interaction, which was marginally significant here, and that interaction is coming from that the piglets born alive were reduced by 0.2 piglets in sows with high energy intake, but there was no evidence for difference in Gilts in that case. And this was coming from the stillborns. Okay, so you can see again, there's a parity by energy interaction where stillborns increased 2.1 percentage points in sows with high energy intake, but again, no evidence for difference in Gilts. Also, there is a lysine effect. Regardless of energy level and regardless of parity, increasing lysine reduced 0.7 percentage points the rate of stillborns. Now as we move to one of the main goals here of our experiment, which was the litter weight, as well as the individual piglet birth weight. First, let's take a look to the litter birth weight, and now look into the total number of piglets born. Okay? You can see there is no effect of the dietary treatments. However, there was an effect of parity, where sows had heavier litters than Gilts. Now, as you look to the born alive only, okay, there is similar trends here where there is no effect of the diets. However, again, sows had a heavier litter birth weight than Gilts. Now let's bring that to the pig basis. Okay, so the individual piglet birth weight, here considering all the piglets in the litter, there was no effect of the diets, and again, sows had a heavier pigs than Gilts. When you look to the born alive, it was interesting because we observed an increase in that piglet birth weight, considering the born alive only, was a 30 grams improved when we increased the energy compared to the low energy. Okay? You can see there is no effect of the amino acids when you compare high versus low amino acids here. Another interesting finding is that, again, sows had heavier pigs than Gilts, but you can see that it was 9.7 grams, where the nutrition approach was at 30 grams, to show that relative impact on that individual piglet birth weight. As we look to the coefficient of variation within the litter, there is no effect of the diets, and as expected, sows had greater variability on their litters compared to Gilts. As we look to litter size after cross-fostering, here we wouldn't expect any difference, and they were flat, as you can see, no effects. Here is interesting, we observed an effect of lysine on pre-weaning mortality, where pre-weaning mortality was reduced on 1.2 percentage points in piglet suckling from high lysine intake compared to low lysine intake. As we move to the intra-estrus interval, there is no effect of the diets, And this was another one that was interesting because we were definitely expecting a greater inter-estrus interval for this low energy, low amino acid intake. However, there was no effect, and only we can see the parity effect where sows had a shorter Wean-to-estrus interval compared to Gilts. Here, as we move to the subsequent performance, so those Gilts from the first cycle, of course, here they are in the next cycle, but you can see that there's no effect of the dietary treatments. However, sows had a greater farrowing rate than the P1 in this case. As we look at total born, similar trends here. We are not able to observe any effect of the dietary treatments. However, sows had a greater total born than those Gilts in that subsequent cycle. Let's look to born alive, similar trends, no effect of the dietary treatments. However, there was an effect of parity. So to summarize the findings, as far as body weight gain, there's a greater magnitude of gain when we increase lysine and energy at the same time. When we look to stillborns, high energy intake increased the stillborn rate in sows by 2.1 percentage points, but there was no effect in Gilts. As far as piglet birth weight, when we look to total born, there is no difference between the dietary treatments in the litter birth weight or in the individual piglet birth weight. And as we look to born alive, there is a positive effect of energy here in the individual piglet birth weight, which was 30 grams, 0.07 pounds, compared to low energy. However, in the total litter base, we are not able to statistically observe that difference. And the coefficient of variation within the litter, there was no difference. As far as pre-weaning mortality, piglets suckling from females fed high lysine were associated with a reduction of 1.2 percentage points in that pre-weaning mortality. As we look to Wean-to-estrus interval and the subsequent performance, there is no evidence for difference between the dietary treatments. So 3 take-home messages here are: the first one, the stillborn rate was increased in bump-fed sows, but not in Gilts. Energy influenced the individual piglet birth weight of those born-alive piglets, but lysine failed to impact that birth weight. And lastly, the individual piglet birth weight of the born-alive piglets, again, increased 30 grams in females fed high energy. However, the impact of parity was over 3 times more than that effect of the energy.